Good morning. Can you hear me? How's the sound? So I sent you Unit 3 material. I'm hoping that you are working through the remaining problems in Unit 2. You can ask me after this class. Well, I think I'm going to spend the whole class on this topic, but maybe you can email me or connect with me about questions you have with the previous material, any of the handouts I've shared. Some of you have asked for your assignment grades your test grades, and I apologize, but I'm not done. I have 2 sections of this class, and I believe I gave the same test. Yes. So, see, I have so many things going on that I can't even believe I asked that question. So yes, I'm still finalizing those, and I really want to finish it today, but I'll do my best. You need those grades, and you did well though. I mean, in general, I was happy with what I saw. Some students even answered question 5 properly. All right, so you have the notes in front of you. You're ready to go. We're on to Unit 3. So everything we learned before is examinable. Those are tools that you should have in place. And what we're going to do now is use them. We're going to use our tools. We're going to begin looking at valuing projects. So we spent a lot of time on valuation of assets, right? We spent time looking at valuing financial instruments like stocks and bonds, also working with loans and mortgages, and we talked about what else? And then just investment opportunities. So this is what we're going to focus on now, or choosing among alternative investment projects and using different criteria for it. And you guys can let me know if you've learned this before, but you've learned net present value, and we're going to begin with the net present value rule for helping decide if you should invest in a project or not. But we're going to go beyond that. We're going to compare alternative projects using NPV and discuss other ways to do the same thing, and then the relative strength of different approaches, right? So this is going to go fast. It should just take one in a class and just a bit of the next week class. I've also sent review exercises for you so you can practice, okay? So on the next test, I will include Unit 2, Unit 3, and probably some of Unit 4. Some basic stuff from Unit 4. So Unit 4 I'll send next week. All right, so first we need to know the difference between, to understand the difference between objectives. So what if we are choosing to fund several potential investment projects, okay? So we have several that we've analyzed and we've prepared, like the cash flows, future cash flows that we anticipate, that is revenues minus expenses, and for the duration of the project. And we want to figure out, should we pursue it? So the question, should we pursue it, is an analysis of an independent project. Accepting or rejecting one project does not affect the decision of other projects. And for each method, we're going to talk about criteria for accepting or rejecting the project. And I've been very general here because there's different types of approaches that we're going to discuss. Second is, well, maybe you don't have enough money to pursue all projects, you don't have enough capital, so we're going to have to choose one. Now, how do you do that? You're going to have to come up with a technique of analyzing them and then ranking them best to worst. And so we're going to talk about mutually exclusive projects when we talk about that. And finally, maybe we can fund more than one, but not all potential projects. This is a case of capital rationing. There's not enough capital to invest in more than one, but not, sorry, there's enough capital to invest more than one, but not all alternative projects. All right, so what's a project? Give me an example of a project. Give me an example of a project that a corporation or a company might pursue. So imagine which kind of company and then what kind of project you pursue. You can put it in the chat just to put you in the driver's seat. If any of you would have a company in the past or you work for a company, what would be something that they might be looking at for expanding, growing the company? Or maybe saving money. Maybe that's what they're interested in. So an example could be the university is looking at renovating the amphitheater, or the theater. We have that theater, and it's historical. It has historical value. I think there's some issues about restoring historical artifacts or historical locations. So we're going to look at possibly renovating and generating revenues to pay for that after the fact. So we're going to have concerts in there, and yeah, so that's the project I suggest. What kind of projects could you come up with? So think about a company, and are you awake, the 10 of you? I'm waiting. What about a Okay, multi-stores, parking, office renovations. Very nice. Okay, good. What about training? You want to train your personnel in new software, and you have to hire trainers, and then you have to pay them for their time on weekends to go to the training. So that could be another project. Implementing a cloud software allow employees to easily store or work on company projects together. Good. See, you're giving me ideas for problems, different cases I can create. Very good. One more. The gentlemen are saving us. It doesn't have to be perfect. Something else. How about looking at the cost savings from closing an office, but then using the savings? So if you have many offices of an insurance company around the island, closing one office and then using the money for outreach, developing a website. Okay, I'm not going to get another one. Okay, you guys get the idea. All right, so we begin with the net present value. We already know about the net present value rule. We will take the initial investment cost and offset it by the total present value of future cash flows. And as long as that's a positive, we should invest in the project if these are independent projects. But if we have to choose one among several options, so it could be that we're looking at training or like training our staff, or we're looking at hiring new staff, and we're going to compare those two and all the ramifications. Okay, so those could be projects. We have to pick only one of them. In that case, we would calculate the NPV and choose the highest NPV among the alternate projects if we could choose only one. So what we have to do, usually until now, I've given you cash flows and said, okay, calculate the NPV. This class we're going to talk about techniques different from NPV, and we're also going to build towards the next unit where we discuss how to estimate those cash flows, okay? So estimating those cash flows, it's just an estimate, right? Maybe you want to make alternate projections of cash flows in case your estimate is wrong. So you'll have some like higher values and then some lower estimates, and see if you still make the same decision with those estimates. You need to know how much and when those cash flows are occurring. Now, recall that we always talk about end of period cash flows, but in fact, revenues could happen all through the period, right? Expenditures happen all through the period, but we summarize them, we estimate them as end of period just to facilitate the ease of calculation. And we need a discount rate to do all of this. And sometimes, I know that's not easy to come by. Like how, what do we have to think about when we think of what discount rate to use? We have to think, well, if we're not investing in this project, we would be using the money and it would have this kind of rate of return. So that would be the discount rate we could use. And you can see it's pretty vague. You can imagine it might be vague. You would have to pick among different discount rates. So I'm going to teach you about a way to look at project valuation without a discount rate, a firm selected discount rate. Okay. So we begin with a first. Oh, did I do both slides? Yeah. Maybe not. All right, so here's the first project. Assume you have the following information on project X: the initial outlay and the required rate of return. Annual cash revenues and expenses are as follows. draw a timeline and compute the NPV. So because I've gotten these together, I just need the net revenues, right? I've collapsed them into these figures. So we look at the NPV as discounting the future cash flows and offsetting it with the initial cost. And in this project, you guys can practice with your calculators if you haven't done this in a while. I'll give you a moment to practice getting this result. It is 377.02, which implies that it's profitable to pursue the project, so you accept the project. So practice entering that into your calculator. I'll give you a moment. Got it? All right, so that's the net present value rule that you remember. Wondering if I should do it. So we use the CF keys. I need to clear it, second clear work, and then I enter 1100 negative as my initial cash flow. Then I scroll down, and the next one was 500. 500. Enter down, and frequency, there's just one of them. And then 700, down, and then it's negative 500, right? So you could ask, why is that? Why is it negative? Well, you know, we anticipate, oh, I had the sound off. All right, so I'm just doing this for you. So yeah, you get a negative. You can anticipate some sort of loss in the third year. Down, down. Oops, wait, what happened? So I entered down, down, and then 1200. And is that it? Did I do it right? 4 periods. Then I have to ask for NPV, and it asks me for the interest rate, which it's 10%. So I enter 10, enter down, and then I compute my NPV, and it's done. All right, so that's NPV. No questions. So again, these values come out of some projections, possibly about what has happened in the past or other firms that have done similar things and how they fared. So all that information goes into getting those cash flows. All right, so that's NPV. Now this is a new type of rule you might not have heard of. It's known as the payback period rule, whereas NPV uses dollars to evaluate. The payback period rule uses number of years. So payback period rule uses years or periods. I'll just write years. Or time. Let's write time. That's more general. So it focuses on time. So what are, in particular, if I'm going to invest, I want to know, when will I recover my costs? That might be a priority for me, more important than my net profits, because I need the money back right away because of other projects that I'm involved in. So the payback period rule is a technique of computing the number of years to recover the costs, and if we're looking to choose every project that satisfies the criteria will be, I say here, set by management. So you could say, well, you know, accept all projects that are less than 2 years. So you accept all the projects with payback period less than 2 years. I can get rid of the R here, maybe. Just call it payback period. I think I fluctuate between using the longer acronym. Ruben, would you like me to do that NPV again? So here, for this problem, I entered the values into CF, and I entered the initial cash flow, the 500, 700, negative 500, and 1,200. So everything's inside. Then I ask for NPV. Now, initially, the 10 wasn't in there. I had to enter the 10, so you have to write 10, enter, and scroll down, and then compute. So it's, I guess I have to start over. So I have to go here and clear it. So CF, the initial cash flow is negative, then it's 500, enter, down, down, 700, enter, down, down, 500 negative, enter, down, down, 1200. Then as for NPV, you have to enter 10, enter, down, and then ask for NPV, compute. We did this before, but anyway, if you're learning now, that's good. All right. Can you get that, Ruben? Ruben? All right, so the payback period rule is a measure of time to recover costs of the project. So for instance, it might be several projects and you have to decide if you're going to accept them. The rule would be set by management, accept projects with payback period, for instance, less than 2 years. Or you want to invest in the project that pays back soonest. You can rank them by the years that they pay back or take to pay back and pick the project that pays back the soonest. But probably you want to combine that with some measure of NPV. So I don't feel payback period rule is used in isolation. It's used together with other criteria rules, right? But it is good to know, right? When does the project pay back? When do I recover my costs? So how do we consider this? Is this a good approach? What are the shortcomings of doing this? As I mentioned, you probably don't just want to think about when does a project pay back, because future cash flows might change your mind. All right, so let's say a project pays back in 2 years and it meets your criteria, but in the 3rd year you anticipate huge profits. So you'd have to convince management if you're working for them, or you'd have to make a decision if you're going to ignore those profits in the future and favor stick with the 2-year rule, or use both criteria together. Okay. The other thing about this that we have to be cautious of is that I haven't mentioned anything about discounting. Okay, and we know that there's a time value of money effect. Here's an example. Here is an example of how to calculate the payback period. So here are, here's the initial outlay of this project. Here is the cost of capital, which represents the discount rate we will use. So it's cost of capital is like opportunity cost or discount rate. They all mean the same thing. If we were to just look to pay back this amount, it looks like we'll recover our $1,000. So that's going to be, so just look here for now. Actually, you know what I'll do? I'll just pull it away so it's not so confusing. Okay, so let's say this was, actually I have to take all this with me. So if we were to look at this, you make another column, call it accumulated. You know what? I gotta make this bigger. I can fit it in. So if I was to add or cumulative, I'll say cumulative. That's better. I'll just leave it for now. Okay, so this would be 200 after the first year, then 600 after the second year, so it's still not enough, and then 1,300 after the third year. So it's in the third year that it pays back, right? Because it'll pass the 1,000. Now first, let's be more precise about that. At what point in the third year will it pay back? How do I figure that out? Well, I'm going to use this rule here. So this rule is take the closest year and then add a fraction. You need a fraction of the following year, year three's cash flows. You need a fraction of those, just, in this case, just 400, right? So you need 400 of the 700. You don't need all of it. So to calculate, sorry, I dropped my pen. Okay, so to calculate this, closest year is 2. And now it's not always 2, it's just my examples seem to have 2 years, but it could be more, right? In this problem it's 2. There's $400 remaining, and you spread them out over 700. So the payback period is equal to that. What do you get? So I'm doing this without the PV. I'm doing this just as the payback period to teach you the payback period, Diego. Discounted payback is something else. I mean, obviously it's related, but this would be the payback. So this is a very easy calculation somebody could make without even needing a calculator. So when you sort this out, you get 2.57 years. So how do you evaluate that? Okay, so I guess I have to fix this formula to make it make more sense. There. Correction. That's why Diego was complaining. I'm doing this without the PV. So you still have, it's 600, we need 1,000, so $400 remains, so it's $400 out of the $700. No, it's cash flow in year 3 is 700. And what remains, it's 600 that we've paid back, we've got back, recovered, and that, and 400 remains. I'm glad you guys are asking questions. So 400 is the remainder of what's left. So you've recovered 600. That leaves right, good. So it's 400 that remains, and you'd spread it out over the 30-year revenues, and you get 2.57. Unless I made a mistake, I get 2.57 years. So this is, then you have to take this and say, okay, well, is that enough? So it depends. What if management says, you know, we're only accepting projects that pay back in 1.5 years? If that's the case, then you reject the project. Okay? So it all depends on what is established, and that's going to depend on their other objectives, other things. Other priorities. So this is how you calculate the payback period. So you noticed I had that expression, the PV, here, because we know that there's a time value of money effect. We want to take account of that. Let's see if well, it'll be worse in this case. It'll take longer if we discounted our cash flows, but let's do it nonetheless. So if you go back here, so this is how we would calculate for discounted payback. We'd have to create this column. So these are discounted cash flows. So this would be okay, so those are the discounted cash flows, and I create a column for them. And similar to what I just did, I create a accumulated discounted cash flow column, and that's what I do here. So I'm adding as I go along. So in the first year, 182 in present value dollars is recovered. In the second year, it will be a total of 513 by the end of the second year in present value dollars. By the end of the third, it will be this amount. So this is clearly much less than what we were dealing with before, right? That was 1,300. Now it's only it's only 1,000, a little bit more. So same rule, but we're going to use these figures. Sorry, these figures here, the present value of the cash flow. Same rule. I'm going to go to the closest year, which is 2, and I'm going to add a portion of the third year that is a fraction created by what remains. So what remains is 1,000 minus 513, already recovered. So 487 in the numerator, and then 526, this number here, in the denominator. Remember, you have to go back to these ones. This was just used to figure out what remains to collect, to be collected or recovered. So this is a much bigger number because our cash flows were discounted. So certainly with a rule of 1.5 years, this would not be accepted. Okay, so we use discounting because we understand there's a time value of money effect, and we want to incorporate that into our analysis. So what we have with the payback period or the discounted payback period, is another approach, another consideration when evaluating a project. Decision makers may or may not use it. So even though we've looked at the discounted cash flows, by just looking at the close, the years, the near future and not the long term in your calculation, notice we didn't use all the calculations. Like I didn't even incorporate this number into my calculations. All right, I didn't even think about it. But what if this was like, what if it was 4 million? Shouldn't I consider it in my calculations? So you'd have to justify that that's a really good estimate. But in fact, you wouldn't want to use payback period rule in isolation. NPV would capture that number because NPV uses all the values in our calculations. All right, so that's all I'm saying here. What are the disadvantages? Even though it's so simple to do, the maximum acceptance criteria is arbitrarily set by the management. And 2, it doesn't consider all cash flows. It may be missing important information about future, possibly detrimental or windfall cash flows. So it's another consideration. What if you are accepting the project because it pays back in 1.5 years, but in the 3rd year, we anticipate a huge loss? We'd like to consider that as well, and that would be picked up in an NPV analysis, so we probably use both. So this information could be used in decision making of your own, or if you work for your supervisor and he's asked you to look at this, or she's asked you. All right, what next? So here's another one. Here's another rule. So far, just to recap, we have NPV, which returns $1 value, and we have the payback period rule, which gives you time to pay back, and we have the discounted payback period rule, which also gives you time but takes account of the time value of money. And now we're going to talk about the internal rate of return. This is going to return a percentage to you. Now I'm going to return to this slide later because it will make more sense as we progress. So I'm going to return to this in review. Sorry for the noise. I think that's a generator just turned on. It's very loud. Okay. All right, so let's look at internal rate of return, and I'll explain it as we go. So here's an investment project. We've estimated these cash flows. The initial outlay will be $2,200. Now, when we look at these cash flows, you can imagine these are presented in thousands of dollars, if you like. So these are really $1 million figures. This is $1 million. This is 800,000, 900,000. Okay, so these are practical. I use the smaller numbers for practical reasons. So find the internal rate of return such that NPV is equal to 0. So what am I saying? This project is an investment project. In particular, that is, we invest money and then we anticipate future net revenues. So I could calculate the NPV of that project and analyze it like before, but right now I want to introduce you to the internal rate of return concept. Internal rate of return satisfies this expression. Set the NPV to 0 and determine what is the return the intrinsic rate of return for this investment. So you're finding like the break-even rate of return or return on investment. So notice this looks just like NPV, but I put IRR in here. I could write it like this. I could also write it like this. And if you are using our calculator, this will be fine. If you are using Excel, I think this form of the equation is helpful. But anyway, in either case, what you see here by writing it is that these future cash flows are reduced as the internal rate of return increases, right? So as the discount rate goes up, the denominator goes up, but the overall value goes down. So this is if I consider different internal rates of return to put in this expression, notice I cannot isolate IRR. This is not possible. You can't do it analytically. You cannot isolate IRR on one side and solve for it. You have to use a computational method. Your calculator or Excel will solve this. We're focusing with the calculator this class, so that's what we're going to do next. But I just want you to see the pattern. Looking at higher and higher rates of return, this entire amount decreases and is less able to offset this amount. At some point, so this is a function in IRR that as IRR increases, the function goes down. Does everybody see that? Because there's no IRR here to talk about. So it's a decreasing function. And it turns out that because these are all positives and this one is negative, it's going to be a monotonous function or monotonous. It's just in one direction. So it actually ends up looking, oh wait, we're not going to do that yet. It ends up looking like this. I'm going to talk about, so this is the function with internal rate of return plotted here and the net present value plotted here. And you see the function falling until it crosses where there is NPV of 0. And this is what we're interested in. Where does it cross? Where is NPV 0? Where NPV is 0, IRR exists. All right, so looking further at this graph, for all these levels of the discount rate, what do we see? What is NPV, positive or negative for all of these? And just answer the question and then I'll get into the detail. So for all these levels of the discount rate, what do we see? The graph is here. So at this level discount rate, what is NPV? It's a positive. At this level, what is NPV? It's a positive. NPV is always a positive until here. Then what happens? For this level of discount, the function, this is the function, for this discount rate, NPV is negative. So the internal rate of return indicates where the project is unacceptable. As long as you're using a discount rate that's smaller than this internal rate of return, you should accept the project because the project will be a positive NPV project. So that's what this says. Accept the project as long as the internal rate of return is bigger than the required rate of return. That's what that means. Let me know if it's really loud. Maybe I can go in another room. That's terrible. Okay, so this is your cost of capital, your discount rate. So as long as it's bigger, that means your function will end up being a positive NPV. So this is, let me go back and we'll talk about this again if you still didn't get what I'm just doing here. What I'm doing is I created a function that looks like the NPV, but I want to find out where that NPV is 0. And it will, I want to find the discount rate where NPV is 0, and that will mark the maximum internal rate of, the maximum discount rate that I can use. So what is it telling me? It's giving me a sense of the return on the investment, okay? It's giving me an idea of the percentage return of the investment. And as long as that meets the minimum required, right, the required rate of return, I should accept the project. So let's see how we do this, and then we'll talk about it some more. So what I've done, what you would do without a finance calculator is you would essentially create that graph, different discount rates, and keep computing the net present value until you see it cross over. So here you see, because as I mentioned to you, I'm guaranteed that it's going to be a downsloping function because the first cash flow was negative and all the rest are positive. It works out that this is going to be downward sloping, and the internal rate of return is in here, because in here NPV is 0. But that's the best I can do if I don't have my finance calculator. So let's generate this, and then I'll show you the faster way to solve this. So let's take these cash flows . And let's go to the calculator, right? So to the calculator, oops, what happened? It changed on me. So I want to put this information into the CF keys. I'm going to I have to click CF and then clear work. And I begin with 2200 negative, enter. No, that didn't work. I missed it. Negative 2200 negative, enter. And scroll down. Then 800, enter, scroll down. 900, what did I just do? Did I say negative? No, 800, right. Okay, so then 900, enter, scroll down. 500, enter, scroll down. And 1600. nice big return at that point. So I've put them all in, and I don't have a discount rate to enter, right? Rather, I can just ask for IRR. So enter all the values, ask for IRR, and hit compute, and there you get your answer. Let's talk about it. You get it? Should I do it again? Okay, that's clear. So if I hit CF, I have to say second clear work. Then I begin 2200 negative, enter. Scroll down. Now I enter 800, enter. Scroll down, there's only one 800, so I continue. 900, enter, scroll down. 500, enter, scroll down, and 1600, 1600, enter, scroll down. And now hit IRR. And compute. So I've taken time to explain what this is. If you didn't get it, I'm going to repeat anyway. I'm taking time because anybody can punch in some numbers and get a result, but what does it mean? You have to know how to use this number. What does it mean and how to use it? So we got 23.295. We can just say 23.3. So 23.3 I put a blank page here if you want to print it and write out notes for yourself. So it turns out that it's in here, 23.3 % is the IRR. And it's the return on the investment. Okay, it's the return on the investment, and as long as that's bigger than the required rate, you should invest in the project. So what is the required rate? Did I give it to you? So I didn't give it to you. So you might not have a discount rate. You just want to present a range of discount rates where a project will be acceptable. So the range would be accept the project as long as you've met the expectation. You have, the discount rate is smaller than what you got for the internal rate of return. So you accept the project, and another way to say it, as long as the internal rate of return exceeds what you require, accept the project. Let me write that backwards. Let me write that the way I did over here. And so all right, so it has to be better. And it is 23.3%. All right, so let's now generate this table here that's called the net present value NPV profile. Now you would use this in the case that you didn't have a finance calculator, or if there are multiple internal rates of return, and I will be talking about that as well. So we need to learn how to generate this. So how do we generate this? Well, all I'm doing is varying the discount rate and computing the NPV for that set of cash flows already entered at the calculator. So I'm just going to repeatedly change the discount rate and get different values. So let me show you how to do it, and then I'm going to give you a bit of a break because I need to get some water. So let's see. I'm going to put 0 and 5 in. So remember these numbers. This one was 1600 and this one was 1126. So 1600 and 1100. So I'm going to change. So these are my cash flows. They're in there already. So all I'm going to do is ask for NPV and enter different discount rates. So first 0, enter down, and then compute NPV. You see? Does that look familiar? That's the first number. If I hit NPV again, I could put a different interest rate. I'm going to put 5, enter down, and I have to recompute NPV. Remember this number? 1126. All right, so that's what I'm doing. It's a very simple thing. Once you have the cash flows entered, you can just keep on changing the discount rate. So let's continue. Let's put 10 in and get this number and 15. So we need 739 and 419. So 10 and 15. So I'm going to hit NPV and I put 10, and I ask for, I put down and ask to compute. So the trick is to use the arrow to go down. So 739.55, that's right. And now I want to again enter 15, enter, and then scroll down. Now if you have a different calculator, you have to figure it out. How to use that, if you want my help with that, let me know. I've sent students using the TI-84, I've sent them manual, well, I don't know, call it a manual, but some lecture notes with the instructions on it, if anybody needs those. So this is how to get the NPV profile. Okay, let me give you a few minutes break. Well, I'm taking a break. You guys can take a break too, but try and finish this. Make sure you can generate the NPV profile. I'm gonna take 5 minutes. Wow, I went over. All right. How you doing? Comments? You got the profile? You follow at least the steps, and now we're going to go back to the interpretation and continue with some different types of problems, or similar but variant. Okay. Let's see. So then what I was saying is the NPV profile, if you were to plot each of those points, they would appear along this curve, and this is where we cross. So here's where NPV is 0. And IRR is worked out to be 23.3. You should accept the project as long as the return, the internal rate of return exceeds the discount rate. And that is also telling us that for all the discount rates below that, we would accept the project. So this means that you don't have to have the discount rate. You have to have an idea. It doesn't have to be precise, but an idea of what you want the discount rate to be. So you notice in the problems that we've conducted, I give about 8 to 10% as the discount rate. Those are reasonable because if they weren't investing in different ventures, that money could be invested and get a return about 7% on some mutual funds, or an average of 11% in the long term in the stock market. So those are alternatives for the capital, right? Those could be invested in different ways rather than pursuing these projects. So that's why it would be a required rate of return to be around that figure. All right, so this is the next problem we're going to do. And what's the difference between this problem and the one we just did? Let's reflect a bit. No comments? So the difference is that this is a finance project. It means that we have initial upfront financing. So we could have made an arrangement to borrow this money in a corporation. Maybe we issued debt and collected, raised this much capital, but then we have to pay it back and also unfold, deliver the project, and these would be the cash flows as a result. So initially we have upfront money, but then we have to disperse funds. So this is the opposite in terms of the mathematical sign. So how will that affect things? Okay, well, I want the NPV to be 0. So here's the equation that would represent the origin of the internal rate of return. And now looking at this as the internal rate of return increases, so these would increase. If I consider different values of the internal rate of return, the denominator will increase, but as a result, the values, each value will decrease. So this part of the function will be decreasing. It's a decreasing negative, so it is actually, a decreasing negative is actually rising up, right? So it's rising up, becoming a smaller and smaller amount, offsetting the 4,000. So this is actually an increasing function. So once you flip the signs, you flip the curve. It's also a monotonous function. It's all increasing. I could also write it like this. So what it generates, this would be the NPV profile. Again, entering those cash flows, let's do that. Let's enter those cash flows and then we'll see those numbers, okay? So entering these cash flows, into the calculator, so I have to go to my sea of keys and clear it. Second, clear work. Then I begin. 4,000, enter, scroll down. What happened? I think I did something wrong. Let's go back. So 4,000, enter, down. Oh, just once, sorry. The first one I just have to enter one. 1,200, negative, enter, down. Frequency 1, and then 800, negative, enter, down, down, and then 3,500, negative, down, down. And I asked for IRR and compute 14.4%. Comments? So that's 14.4%. Or 37. Okay, so we got 14.37%. What does it mean? Here is the NPV profile showing that the values are getting less negative and becoming positive. As they change sign, it becomes obvious that the NPV is in, sorry, the IRR is in here, NPV equals 0 somewhere in here. So this is where you find the IRR. So what does the IRR mean now that we've flipped things? The graph will help us understand. Here is the graph. Here is the graph of the NPV profile. As I promised, it's going to be increasing. It's going to cross. This is 14.37 here. And then what do we see? We see that at these discount rates, the NPV is positive. So as long as the discount rate the firm uses is greater than the IRR, the project will be profitable. We should accept the project. So everything reversed. The signs reversed. It's now positive and then negative future cash flows. And what else reversed? So that the function reversed and the interpretation reversed. So everything reversed because of the sign change. So what does it mean then? Because we're seeing this as a finance project, we're interpreting the rate of return as a borrowing rate, and we like low borrowing rates. So we want our discount rate to exceed the borrowing rate. So that's why we write it like this. So as long as the discount rate you use exceeds the internal rate of return. So now, because it's a finance project, we interpret the required rate of return, the internal rate of return as a borrowing rate. We want it to be lower than the discount rate. Okay. So if the internal rate of return is lower than the discount rate, accept the project. Our required rate of return, for instance, if it was 15%, then we should accept this because the borrowing rate is lower. However, if it's not lower, we would reject the project. For instance, if the required rate was 10%, our borrowing rate is too high, we should not pursue the project. So in conclusion, for investment projects, you make sure that you accept the project as long as your rate of return on the investment, internal rate of return in other words, is greater than your required rate. What's an investment project? The first cash flow is negative and the rest are positive. There's only one sign change. A finance project is the reverse. Okay, you should accept it as long as the required rate exceeds the internal rate of return. So the internal rate of return represents a borrowing rate. You want it to be lower than what's required. And in this case, how do you recognize a finance project? The first cash flow is positive. There's only one sign change and all the rest are negative. What did I just say? Yes, that's what I meant. Positive and all the rest are negative. All right, let's see. That's the drawing. Let's look at the NPV profile. Where's my NPV profile? That's the NPV profile. So try and generate these. Let's remember the numbers. The first one is negative 1,500 for 0, and for 5 it's 891. So let's do that together. So I already have the numbers here, and I hit NPV and I use 0, compute, 0, enter, down. Then compute. There it is. Let's do the next one. NPV, let's enter 5, enter, down, and compute. 891.91. So these are the numbers being generated in the profile. Okay, any other comments? Okay, so if you have your finance calculator, you obviously we could get this very easily, but there can be a moment where you won't get it, and that's what we're going to discuss next. So that's why you need to learn the NPV profile approach. Here's the example. So what if you have multiple internal rates of return? So how can that happen? Well, I've emphasized many times that Okay, so Diego, this is when we're talking about the discount rate. You're talking about this example? So the discount rate that we use, we set. We don't have to negotiate that with a bank per se. It's the rate that we use for our projects, that we want our projects to meet a certain criteria. If we're not so sure about the rate of return that we want or require, we use IRR to get an idea of a range of rates that are acceptable. So as long as here your required rate is higher than 14, in this finance project you should accept it. So again, who determines what you use? That's a management decision. That's a decision regarding opportunity cost. If we didn't invest in this project, we'd invest in another one that would earn such and such a return. So that's what determines this rate. Required rate of return. Anyway, let's see. I'll get through some more and then I'll see if I answered your question. All right, so it might be the case that you have multiple rates of return, and that happens when there are more than one sign change. So here we have the initial cash flow is a negative, so it looks like an investment project. We have a positive future cash flow in the first year, and the second positive, and the third positive, but in the fourth there's going to be a loss, a net loss. And mathematically that's two sign changes. When there's two sign changes in this polynomial, the curve turns into like a convex function or a concave function. And I've drawn these to show you some examples. Let me just show you what I'm talking about. So it could be like this. Make it cross better. It could be like that. It could cross in two places. Then what should you do? So this is the NPV profile with NPV here and the discount rate here. What should you do if it crosses in two places? Where should you fund the project? When? Could also be like this. So the rule is we haven't abandoned the net present value. Obviously, we're using the net present value to evaluate or determine the internal rate of return, right? We're setting NPV to 0 and evaluating. So don't lose sight of what the NPV rule tells us. We should invest in a project as long as the NPV is positive. So in here, let me make that a little finer. So in here and in here. All right, So in that region, oh no, not in there, that's the opposite. Sorry, in here. That's where NPV is positive. Right? So that's what we're going to use. We're going to determine the curve using the NPV profile and assess the discount rate, if we have one, that the firm is using, and decide if we should invest in the project. What if the curve looks like this? What do we do? So this is the NPV profile. NPV is always positive. There are no IRRs at all. It never crosses the 0. What do we do? Always invest. No matter what the discount rate is, you should invest. It's always positive. What if there are no IRRs here? It never crosses, but we're always below. In other words, net NPV is always negative, since no matter what the discount rate is, never invest in this project, no matter what the discount rate is. Very good. Okay, good. So those are the criteria. Those are the decisions. So you can see we have to create the NPV profile. Our calculators, if you have the TI BA2 Plus, the one I'm using, it only calculates one internal rate of return. If you have the HP 10B2 calculator, it calculates both, or all. So I used to have the students buy the HP, but it was much more expensive than the TI. I don't know, in the future I'm just going to stick with the HP. But this way I force you to make the NPV profile, and that's really what I want. So that's why I continue to tell my students to use the Texas Instrument. But if you were going to write the CFA exam, you could probably borrow or get an HP calculator, figure out how to use it. So let's do this together. We're going to generate for these cash flows here the NPV profile, all right? Do I need to bring them with me, I wonder? Here, okay. All right, so let's enter these into the calculator and generate this profile, and then we'll talk about these results. All right, so let's, I did it again. All right, second, clear work, CF, second, clear work. So all these worksheets have to be deleted, the NPV ones, the CF ones, and we begin negative 260. So 260 negative, enter, scroll down. 250, enter, scroll down, and only one amount. So 300, enter, scroll down. and then 20, enter, scroll down, and then we have 340 negative, enter, down. So all the values are entered. And now we ask for IRR, and we ask to compute it, and there is 11.52. So we got 11.52, which gives us the first one. We cannot get the second one from this calculator. If you have an HP calculator, the way it works is you store a number that overshoots 25, well, it has to overshoot this 11, so make it like 20 or 25, and then the calculator will iterate towards this value. And how it iterates, well, I'm going to demonstrate iteration that the calculator could be doing, because remember, it's a polynomial that doesn't have a formula to solve for the rate, so you have to it has to pick certain values to plop into the formula and try and make the formula equate to 0. So it keeps trying and picking values, but it picks them in a strategic way. So we're going to talk about how that's done, and we're going to mimic what the calculator does. So let's start putting these numbers, different numbers in, and generating the NPV profile. So I'm going to put -10. I'm going to keep putting values until I get close to 0. So the numbers are already in here. I enter NPV and put 0, enter down, and compute. Okay, so it's still negative. Let's do the next one. NPV, enter 5, enter down, and compute. Still negative. Let's do 10. NPV, 10, enter down, compute. Still negative. Let me see. These ones started at the negatives, right? So I started here, which is fine. Like, why would you go into the negatives? You're thinking, well, mathematically you might have to start a little further up, and you'll see that in my future examples. So let's continue. So we did this, did we do 10? Let's do 10. That's 10. And then 15. 15, enter, down, compute. Aha! We crossed over into the positive values. So we know NPV is between 10 and 15. So we figured out that NPV is between 10 and 15. But let's expand 10 and 15 to be, let's go to 11, 12, 13, 14. Well, I'll put 15 in there where we have the scores. And for 10, it was -2. All right, so so this is iteration, right? So we know it's between 10 and 15, so we blow up this range and we start picking in here. So let's do 11, 12, and 13. Let's see what happens. We know it crosses over by 15, but we want to get closer to the internal rate of return. So now I'm going to hit NPV. Let's try 11. Enter down. It's still positive. What did I do wrong? 10, 11. That should be 11:52. Let's do 11 again. I don't know what happened. MPV 11. Let's do 10. 10, enter down. compute, and then NPV 11 enter NPV 11 enter down compute. There, I guess I didn't hit compute. So negative 0.63. So this one is negative 0.63. And now you're going to see 12 will be positive. So I'll enter 12. NPV 12, enter down, compute, now it's positive. So now I iterate between 11 and 12 because this became a positive. So all I really need to see, I don't need to see these numbers as much as I have to see the positive or negative. So I can expand 11. I could go 11.5 to 12. So this one was negative 0.63. So I need to determine if I need to go in between here or in between here. So let's put 11.5 in. That will also be a negative, given the answer that I have. So I'm going to go back to here and put 11.5 in, down and compute. So it's negative 0.02. So it's still a negative, although it's very close. And finally, I'm going to see that this will be a positive, and I have to iterate then between those two. So this is iteration. So Diego, I'm showing you how to get 29.84 manually, because you can't get it out of your TIBA2+. You can only get it out of the HP. But I force students to get this calculator, I asked you to get this calculator. Usually in the past it's because it was cheaper than the BA2+. But I realize it encourages you, it forces you to work with the NPV profile rather than just getting the values out of your calculator. All right, which you do need because you need to see the pattern, where it's positive and where it's negative. So if I do this, this becomes a positive here. So now I got to iterate between these two. So then I go 11.5. 11.55 and 11 and 12, I guess. So you just keep on doing the same thing and getting closer and closer. HP 10B2 is the calculator I'm talking about. So what does this tell us? So it tells us that the NPV is negative here, but it's positive between these two. So this, between these two, is where you should invest. So as long as the discount rate for the company, the required rate of return, is between 11.52% and 29.84%, the project will be profitable. So how do you find this other value? Well, you just have to keep making the profile, because there are up to 2 IRRs if there's 2 sign changes. Okay, so there's 2 sign changes. It means there's up to 2 IRRs. So you need to check in the profile until you find 2, and I found 2. So I'm done. So I could find I would know that between 25 and 30 is another internal rate of return. To get it precisely, I would have to iterate like this. So what does it look like? What does it look like? It looks like this. It goes up and then it goes down, as we saw in the NPV profile. You could draw this, you could sketch it. And so you should accept the project provided the required rate of return that the firm is using was established to be between 11.52 and 30%. So that is high. It's a pretty high required rate of return to invest in this project, and it might not be the case. You know, it all depends. But the thing is, the firm doesn't have to give you one discount rate so you can calculate the NPV. You return to them all this range of values and say you can have, this project will be profitable as long as you apply a discount rate between those amounts. So maybe they have capital that they have allocated for more risky projects, and this would fit that profile. All right, so let's continue. Any questions? We have another 45 minutes. Any questions at this point? Okay, no comments. All right, let's continue. Let's look at this project. Let's look at the cash flows. It looks like it's an investment project, but there is a second sign change. So it goes from negative to positive, but then changes sign again. So the polynomial will have up to 2 IRRs. It could cross in 2 places because it's a curve. It will be a curve either up or down. So we need to generate the NPV profile here. So I'm going to leave you with this. I'll give you 5 minutes to work on that, and then I will come back at 11, 10. I guess it's 6 minutes. All right, you done? All right, so let's see. Where should we begin? Is the question. Well, you know, in this example up here, I began back in the negatives. Are we going to need to do that here? Let's cheat. Yes, you got to go back. So if you just use the positive values, you're going to only find one IRR. And mathematically, well, we could just start at 0, but see, you'd never feel confident that you actually found the other one. So this graph tells me, and I will tell you in assignment questions as you work through them, where to start your NPV profile if there is an issue, you know, like this, where it begins back here. So let's just mathematically try and resolve where it crosses, and then we'll talk about the interpretation. So we're going to go back to -30, and we're going to go then to, well, we can make broader numbers, so -20, -10. Actually, you know what, I'm going to just cheat. I'm not sure what you guys did, but I'm going to jump to -10 and 0, and then 510. Sorry, wait. Oh no, I gotta go high. So I'm going to use broad strokes. 0. I'm going to go 10. No, 25, 30. 50, 75, 100. Okay, so I'm using really broad numbers. And then I can be more specific when I find that it crosses over, okay, to a different sign. So let's enter these values into the calculator. So go to CF, second clear work, and start entering 900, negative, enter down, oops, down, 1200, enter down. Let me double check, I'm sorry, I'm rushing. Let's see, yeah, it's -900, 1200, 1300, and -1200. So, as I was saying, that's the first cash flow a year from now after the initial investment of 900. There's only one of them. And then 1300, enter down, down. And finally 1200, negative, enter down, down. So now, ask for IRR and compute. And this is what we get. So we get this one, -29, so that could have tipped us off that we have to go lower, but really all we need is the sign. Make sure that the sign of NPV stays the same in that region up until 0. So what I'm going to do now is generate the profile, and the profile starts back, remember I started at -30, then -10, then 0, then 25, right? So -30. NPV, 30 negative, enter, scroll down, and then compute NPV. So it is a negative. So -30 gives -31. This is -31, and remember this is dollars. So it's negative here, but then because we know it's going to be -29 is the IRR, it's going to cross over right away. This is going to be a positive. So I'm going to put in -10 as the internal rate of return. So it's asking me, so I say 10 negative, enter, scroll down, and recompute. You see, it's a positive 392. So now this is positive 392. And we keep going now, trying to see where it returns to negative. So 2 sign changes in the cash flows indicates up to 2 internal rates of return. If there are 3 sign changes, then they're up to 3 internal rates of return, because it could go, the curve could look like you see? Actually, if there are 3 sign changes, it could be even 4, because it could cross. I've never done that before. It could be four internal rates of return. Okay. Okay, so all right, so let's continue. So I'm going to enter 0, 25, 50. So I'm going to enter 0, enter, down, compute. So that's a positive. So this is going to be positive. Now I'm going to enter 25, enter down, recompute. Still positive. Then 50, 50, enter down, compute. Still a positive. 75. So 75, enter down, compute. Aha, it's a negative. So between 50 and 75, it changes sign. That's the most important thing. So I'm going to just make a note that this is positive, 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 negative. So this is where the IRR. Now, I'm just putting it to find it here, but if you want to graph it, you actually have to find the values, right? For the chart. So now I would iterate between 50 and 75 to get closer. So it would be 50, which is a positive, I said, and then 55, 60. So actually, let's leave it broad again, and let's leave it broad and then zero in on it, target it. So 50, 60, 70, 75. So you know that's a positive, that's a negative. So we'll just try 60 and 70. 60 will turn out to be a positive, and 72, so you'll know that it will be between 70 and 75. So let's do that. I'm going to enter the interest rate as 60, enter down, recompute, positive. The next one will be 2, 70. Positive. So you know the NPV must be in here. NPV equals 0 in here. Right, Okay, so what we found is that the second internal rate of return is between those two, and Diego was telling us that it's 72.255. I guess maybe he got that on the calculator or used Excel, so you guys can practice using different tools. Now the point is to get the interpretation. So here's my graph with the actual values, positive, 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 positive NPV, and then negative. And it's in between here that the project is profitable. Now, no firm will pick an internal rate of return less than 0, because that would mean that they are paying rather than making money to invest. I mean as a return on investment. So really the decisions are here, and this is all positive. So it's pretty much like a for sure project. This should be invested in. It looks like it's always going to be a positive NPV. All right. So I'm not going to highlight the other area because firms will not pick a discount rate in here. So accept the project provided the required rate of return is between 0 and 72.25. Well, thank you, Diego. So you're doing that profile. Excellent. All right. So that's multiple IRRs. And we have one more. I'll just do this one quickly. I'll just talk about it. You guys can practice. Okay, so this one looks like this. So I want to show you this one because it looks different. The NPV will be positive in this range and this range here. So what does that mean? That means that you should accept the project provided that the discount rate or the required rate of return by the company is between 0 and 8.05 or greater than 33.96. Now why does that happen? It looks like it's split. Let's look back at the cash flows. Look what happens. The initial cash flow is high, relatively speaking, relative to the other numbers, it's high. And then it looks like a finance project, so it's flipped relative to the other one we did. That was going down just now. And and then the initial cash flow just offsets the first one, and then this one's kind of big, but look, which is the biggest? The greatest cash flow is way off in the future. So the fact that this cash flow out in the future is high favors low discount rates. Okay, so for this to be profitable, a low discount rate will keep the purchasing power of this amount, right? It'll keep the value of this amount in today dollars. So these sets of cash flow, this pattern favors low discount rates to retain the value here, but there's a lot of high cash flows, this high cash flow here you don't want it to be so offset by these negative ones early on. So at the same time as it favors high discount rate, it also favors low discount rates. When you have, let me think, because these are low. Actually, I would want high for that and low. Sorry, I said it backwards. So this one, you want low discount rates to retain the value here. That's what I said. I got distracted. It's noise outside. That's my excuse. So that one favors a low discount rate to retain the value, and this one, you'd like this to be discounted highly so that it withers away this negative. So there's the conflict that you see resolved this way. So either very high discount rate, so that would be for projects that or capital allocated for risky investments, and this one is for the other alternative is to have a low discount rate. Okay, and both of those would satisfy the NPV criteria, NPV greater than 0. All right, so it's just a blur of calculations. There's calculations become simple, but don't lose the point of what we're doing. The calculations help you develop or draw or visualize the NPV profile so you can make your decision. Okay, so it's 11:30-ish. That brings us, okay, let me do a recap with the first page about this. So this is what I was saying at the beginning. I would return here. So NPV gives you a dollar amount. Payback period rule and discounted payback period rule give you time to recover costs, and the internal rate of return uses a percentage. So in using the internal rate of return, you're calculating the rate that gives you a break-even NPV or NPV of 0. We are making an assumption while we're doing this that throughout the duration of the project, the IRR that you get indicates that all future cash flows are reinvested at that internal rate of return. So you're imagining that this applies to future investments for this capital. Now, if you evaluate independent projects, so you're just determining if you should accept or reject a project, you're just checking to see that your return on investment, your IRR, is greater than your required. There are some issues, though, that we discussed. What if it's not an investment project, it's a finance project? We learned how to deal with that. We just flip the rule. What if there are multiple IRRs, not a single one? Well, we learned how to deal with that. We create the NPV profile, and using the threshold of the IRR, we divide the areas of the NPV profile curve into the profitable and the unprofitable areas, and then we compare where the discount rate would be to decide if we accept or reject the project. And next we're going to talk about this issue, how you resolve this issue. But overall, the IRR is a popular technique. It's very easy to communicate a percentage return and to explain that for investment projects, this is a return on investment. And for a finance project, it represents like a borrowing rate. So these are easy concepts to convey. Just a last point, we're going to talk about mutually exclusive projects. So we're going to talk about the disadvantage that exists, that thing you have to be careful of, and we're going to correct for it and how to deal with choosing between more than one project. So here we have the issue. So the problem with mutually exclusive projects, picking between them, can be categorized as one of two, or either of the two problems. One is the scale problem. Be careful when you're comparing or you're choosing between two opportunities that are have different relative investment in terms of like magnitude. So the lower budget project, for an example, for a low budget project would be, if you give me $1 now, I promise to give you back $1.50 at 12 o'clock or the end of the class. Would you pick that, or would you take this next one? Invest $10 now, and then you'll get back $11 at the end of the class. So this would be a higher budget project. Of these two, which opportunity do you prefer, one or two? which one would you pick? And why? Anybody there? Okay, so Juan tells us he would pick the second one. I didn't understand. Juan, are you picking the second one or the first one? The second one por el 50% or 50 centavos. Okay, all right, so I'm just gonna answer the question because people are not here or not responding. So the thinking would be, well, I'm gonna get 50 cents back on the dollar, so that's 50%. So that's what you would think, oh, 50%. But this is only 10%. So sure, I should take opportunity one. But should you be comparing them that way? Well, no, because one is low budget and the other one is high budget. In the end, which one gives you more cash? This one gives you 50 cents, but this one gives you $1. So the problem, the blind spot, is that you're not recognizing that you're comparing apples and oranges. You're comparing different size projects, okay? So how do we resolve this, and what implications does that have for us using a percentage like the internal rate of return? So so here's the example. If I use NPV, and I even threw a discount rate in there just for fun, it looks like I should choose number 2 because I'm getting $1, practically $1 back. And that's that's more than 50 cents. But if I use internal rate of return, this looks like 50% and 10%. So how I reconcile this is that you cannot use the internal rate of return when you have comparably different projects. Okay, it's not meaningful. So this is an example. So until now, all I did was evaluate independent projects. Should I accept or reject the project? Now I'm comparing two and deciding which one is better. When I do that, I have to be careful about the using the IRR. I have to use it properly. Oops. Okay, so how do I do that? How do I use it properly? Well, before we go there, I want to show you another example like the one the last internal rate of return exercise that we just did. This one, the projects are relatively same budget levels, but we have an issue where our revenue, our net revenue in year 4 for project A is high relative to the other revenues, but in project B, it's high up front. So this is where our conversation comes in about discount rates. Project A favors a low discount rate. That would make NPV of A higher. And project B favors high discount rates because early on are the cash flows, well, relatively speaking, not like really high, but relatively speaking, higher discount rates because the cash flows early on and a high discount rate early on is not going to have too much effect. So how do you reconcile this situation? If you calculated the internal rate of return, it looks like you should pick B. You rank them, you say, oh, this has a higher rate of return. But that's not the right way to compare them because there's a problem of timing here. So what we need to do is figure out where project A is good and where project B is good, and compare that relative to the discount rate that we want to use. So how do we do that? It turns out we can figure this out where they cross over. So in general, if you have comparable projects, you would see, one project consistently below the other project, but in fact, they could cross over just like this one. So project A is the bold line here. That corresponds to A. And this dashed line here is project B. And I've plotted the internal rates of return for A, and here's for B. And you see that you should pick A. It will be give you a higher NPV than B in this range, and B will give you a higher NPV in this range, but both will give you negative NPV at some point. So what we really want to know is this value. This will help us determine, if we don't have a discount rate, if the firm doesn't give us, or we don't have a discount rate in mind, we want to do something like, calculating the IRR and give ourselves a range of values for accepting the project, then this would be the important number to get, because this is the threshold for A being ideal or preferred and B being the preferred. So how do we find that? What we do is we combine the cash flows into what's called an incremental project. So we do that by creating the incremental cash flows. That's what that says. So I am going to take each of these cash flows, subtract in their time period the other set of cash flows. So I'm going to take A minus B. This is called the incremental project, and what it means is pick A rather than B, the way I've done it. Now usually you want to subtract them in a way to make the first one a negative. I don't have to, you don't have to, but I'm just saying that is an easier way to interpret things. I don't know why this is so small. So let's do the subtraction. So 350 minus 250 is like plus 250. So this is 100. Negative. And then this minus that is negative 75. This is 0, this is 75, and this is 150. Did I do that right? So I have them here. Yeah, I did it right. All right, so these cash flows, I put them here, are the cash flows of the incremental project A over B. The solution, the IRR of these cash flows will be 8.07, and this dark bold line represents that NPV profile. So I've left all the curves here, but in fact, the only one you need to look at is this one. And what does it say? It says, yes, accept project A instead of B up until 8.07, but if the discount rate is higher, you should use project B instead of A. And up until where B is a negative, so B is a negative here. So maybe there's too many curves to stare at. So I'm going to give you a chance to look at those before next class, and we can pick up here next time. Okay? And we just have a couple more pages and we will finish this unit. So I will send unit 4. You can begin trying the exercises that I've sent you, and I've sent you the solutions as well. So have a productive weekend, a restful weekend at the same time. And let me know if you have any questions, and I'll continue to work on getting you your test back. Any questions before I go? Okay, have a good weekend.